Solve the initial value problem, y double prime plus 2y prime plus 2y equals 0, and right, we have our initial conditions, y at 0 equals 1, and y prime at 0 equals 2. This one's going to be a little more annoying to do because we have complex exponentials and we're going to have a real part that isn't 0. So we're going to have exponentials times sines and cosines. Let's go ahead and dive in here. So we have the characteristic polynomial that will result from guessing y equals e to the rx. Right, this is 1 times y double prime, so end up with r squared. This is 2 times y prime, so plus 2r. And then this is 2 times y, so it's just plus 2. E to the rx equals 0. So in order to do that, I can't do it in my head. I have to use the quadratic formula. So here a is equal to 1, b equals 2, and c equals 2. All right, so we have negative b plus or minus the square root of b squared minus 4ac over 2a. And we're plugging all that in. It's a negative 2 plus or minus the square root. 2 squared is 4. Minus, I have 4 times 1 times 2. So that's minus 8. And it's all over 2 times 1, so 2. All right, well, that's negative 2 plus or minus the square root of 4 minus 8. That's negative 4. And then over 2. The square root of negative 4 is going to be 2i. So this is negative 2 plus or minus 2i over 2. So then the roots are going to be negative 1 plus or minus I. And right, that's our lambda plus or minus mu, I. And so in here, right, the lambda is equal to 1, sorry, negative 1, and the mu is equal to 1. So that fits into our general solution with sines and cosines as y of x equals c1 e to the negative x, negative 1 times x from the lambda, times cosine of mu times x, so just x, plus c2 times e to the negative x times sine of x. All right, so next step, we have the general solution. Now we need to solve for the initial conditions for c1 and c2. So we already have y of x, so we might as well do the initial condition for y at 0. So that's y evaluated at x equals 0, right, is c1 e to the negative 0 cosine of 0 plus c2 e to the negative 0 sine of 0. All right, well, that's not so bad. So we get c1 times 1, cosine of 0 is 1, so this is c1. But then c2 times e to the negative 0, that's 1, but then sine of 0 is 0. So it's just c1. So then that we also know y of 0 has to equal 1. That's specified in the problem. So c1 is equal to 1. All right, well, what about the other one? So that one is a little annoying. We have to compute y prime of x. Right, in order to evaluate y prime at 0, we have to compute y prime. So I think I have enough room here. So we've got y prime of x equals, all right, I've got c1. All right, so I have an e to the negative x and a cosine x. That's going to be a product rule. So I'll do the e to the negative x first. So that's negative e to the negative x, right? Negative x pops down, becomes a negative 1 when you take the derivative, times cosine of x. Then I have the other half of the product rule, which is the non-derivative of e to the negative x and the derivative of cosine. The derivative of cosine is negative sine, so we're going to end up with another minus e to the negative x sine x. I definitely don't have enough room for c2 there, so I'll go and put that right here, plus c2. So right here we have e to the negative x times sine x. All right, we'll do the e to the negative x part of the product rule first. So that pops out a negative e to the negative x times non-derivative of sine x. And then I have derivative of sine x is positive cosine. So this ends up being a plus e to the negative x cosine x. All right. Then from here we can evaluate y prime at 0. So if we do that, I'm not going to write it all out here. So I have c1. All right. I have negative, let's write it all out. Negative e to the negative 0 times cosine of 0 minus e to the negative 0 times sine of 0 plus c2 negative e to the negative 0 sine of 0 plus e to the negative 0 cosine of 0. So a lot of these will disappear, the sine terms, half of them. This ends up equaling, alright, I have c1 still. Negative 1, e to the negative 0 is 1, so negative 1 cosine of 0 is 1, so I have a negative 1. Then I have minus 1 times 0. So this is really, here it's a minus 0, right? The sine of 0 is 0. It's not that bad. And plus c2. So same thing here, we have negative e to the negative 0, so negative 1 times sine of 0. Sine of 0 is 0, so that whole term disappears, it's just 0. Then I have a plus e to the negative 0, so plus 1 times cosine of 0 is 1. 1 times 1, so plus 1. So that ends up being negative c1 plus c2. But right, I also know what c1 is. c1 way back when, right, c1 was 1. This is actually negative 1 plus c2. And I also know that this has to equal the initial condition here. Y prime, when x was 0, was supposed to be 2. I know this has to equal 2. So that will mean if I add 1 to both sides, we get c2 is equal to 3. So I think I have just enough room to write out the solution to the initial value problem. So it's y of x equals, c1 is 1, so that's going to be 1 times e to the negative x cosine x plus, plus 3 e to the negative x times sine x. And there's a little bit of work to do this, but you have to do it. You have to do the product rule, and eventually you'll get the final solution.